Fire has had a role in nearly every plant community in North America. Plants evolved with fire resulting from lightning, and more recently, fire started by humans. Records of fire history from fire scars found on trees in the southern Appalachians indicate fires were once common in this region. These fires were frequent and low severity, but higher severity fires sometimes occurred. In the Appalachian Mountains of North Carolina, ridgetop Table Mountain pines and pitch pine communities are dependent on moderate to high intensity fires every 3 to 5 years. Growing season burns have been determined to benefit these communities more because these pines gain a competitive advantage over hardwood species that produce basal sprouts. These higher severity fires reduce the canopy to allow more light to reach the forest floor, allowing pine species to regenerate. In these communities, fires also benefit forbs and grasses by opening the canopy and removing leaf litter. Fire has also maintained hardwood forests in North America. Frequent low-severity fires maintain the importance of oaks and hickories in this region. Additionally, the American chestnut was once a dominant overstory species maintained by fire in the Appalachian Mountains of North Carolina. Fire was important to clear leaf litter and open the canopy to allow regeneration. The American chestnut produces an annual mast of seeds that were important food sources for both wildlife and humans. Additionally, this tree produces high-value timber. Chestnuts created forest conditions important to many species. However, chestnut has become functionally extinct because of chestnut blight. The indigenous people of southeastern North America, including North Carolina, affected plant communities through their use of fire. Indigenous people used fire to clear land for agriculture, shape the landscape for better hunting, increase production of fruits and nuts, and clear obstructions from encroaching enemies. In an area that has not burned recently, there's an increase in fuels, including leaves and woody debris, from small twigs up to whole logs. Also, fire suppression promotes the development of a dense midstory of hardwood species. This dense hardwood midstory negatively impacts herbaceous and seedling regeneration because of less available light through shading. Additionally, the dense leaf litter that accumulates in these fire-suppressed conditions limits the seed germination because of a lack of exposed seedbed. As a fire, like those that were ignited by lightning or indigenous people, moves through an area, fuels undergo combustion and are cleared from the ground. This often takes the form of a ground fire that moves through an area, often proceeding upslope. Following a fire, the ground is cleared of fine fuels, while fire-resistant overstory trees often persist. This more open overstory maintained by low-intensity fire promotes understory growth. In a natural fire regime, species that are adapted to wetter, shadier conditions will likely not persist following fires. Frequent low-severity fires were common in this region until the 1900s. Starting in the early 1900s, there was a drastic change in the view of how fire affects the landscape. Rather than being viewed as an important part of maintaining forests in other communities, fire was thought of as destructive. As a result of this paradigm shift, efforts to extinguish fires as soon as possible became the new objective. This was one of the initial goals of the U.S. Forest Service. Table Mountain pine and pitch pine are dependent on fire for regeneration. The serotinous cones of these species require the heat from fire to allow the cones to open and release wind-borne seeds. Furthermore, fires facilitate the germination of these pines and other species by creating increased light through clearing competing vegetation. Fire further facilitates seed germination by clearing leaf litter and scarifying the soil. Both Table Mountain pine and pitch pine are adapted to fire by having thick bark that makes them resistant. Without fire, these species do not recruit and hardwood encroachment occurs. Another example of the effect fire suppression has had in the Appalachian Mountains of North Carolina is the lack of recruitment of oak and hickory trees, with an increase in mesic species like red maple. An increase in mesic species leads to forests that are more resistant to fire. In turn, this shift has a negative effect on wildlife that use the seeds of oaks and hickories as a food source, including mice, turkey, bear, and deer. In an effort to restore communities that are maintained by fire, managers began incorporating prescribed fire into the management of these areas. Trained crews execute fire management plans to restore these communities. A result of the ongoing fire suppression and future climate change, more severe and frequent wildfires are predicted to occur in North Carolina. An example of this was the fall 2016 wildfires that affected the Appalachian Mountains of western North Carolina. The restoration of forests in the region with prescribed fire will be important as the risk of severe wildfires grows. Because Table Mountain pine, pitch pine communities, and oak hickory communities are more resilient to climate conditions predicted in the future, prescribed fires that promote these species can decrease the risk of severe wildfires. In the past 100 years, we have moved away from fire as a common disturbance on the landscape, where frequent fires were ignited by lightning and humans. However, recently, managers have begun to reincorporate fire into the Appalachians after noticing changes, especially the disappearance of ecologically important plant communities. Focused awareness of the role of fire will be critical moving forward to preserve resilient communities which have the integrity to persist.